G'day everyone, how are you going? We're back here in Specialist. We're heading up towards our exams. We've got next week at school and then we're at exams the following week, so pretty important revision here so that we're ready to go. We did a test here on vectors just the other day. It was quite a tough test and the results weren't fantastic, so there's lots of little spots to pick things up. I don't think the test is that difficult, but I can understand that people found that time was an issue. So Specialist is the sort of course you've got to see the question, go, I know exactly where I'm going, and boom, you're into the working. There's no real time to think in Specialist, okay? If you need time for thinking, you're going to run out of time. So when you practice for your exams coming up, please practice as much as possible, seeing there's 4 marks for this question. I've got 4 minutes, get on with it. If it's a question from early in an exam, then you probably should be doing it in slightly less time than the number of minutes, because the latter questions generally are the ones that require the heavier thinking, and therefore you might need more time in those questions. Maybe then an 8-mark question is really 10 or 12 minutes. In the early part of the paper, a 4-mark question probably should only be 2 or 3 minutes. Let's get cracking with this one. Part A, here we go, scroll on up. Right, pretty simple question here, really just saying, here's a set of equations, solve them for me. This should have really been bread and butter in many ways. It should have been an easy 3 marks, but I understand there's still a bit of working to get through. Just scroll up a little further for me. So here, notice this, 2 marks for a clear process of showing what you're doing, okay? Clear process, but wrong answers. You still would have got 2 marks. The 3rd mark is really for getting all the way through to here. So your marks are really stage 1, stage 2, final answer. But if you got this wrong, you could still get 2 marks with clear working. Now this note over here, please, please, please pay attention to that. In the early part of a paper, there's not going to be crazy numbers. If you're coming through to some, I don't know, 15 over 17 or 9 over 13, you've done something wrong, okay? Because this question is talking about a unique solution, while the solution could be in crazy decimals, we're not going to do that. We don't do that, right? Later on in calc section, maybe, but here, the most you would get is something that was a half, maybe a quarter, but really it's always going to be whole numbers. If you get somewhere here and it goes crazy, stop, either move on and say, look, I'll come back to that later, or start again, okay? Now, one of the biggest things, just scroll back up to the question for me, one of the biggest mistakes people make, and it's nothing but a careless mistake, is, right to the top of the question, is taking these numbers and putting them in here. The number of times I look at what someone's done down in this part and I go, oh no, they've made a mistake somewhere, and I'm tracing back through trying to find, and then I go, oh wait, they copied it wrong. So if you get crazy numbers, stop, check that you've got this set up correctly, and then recheck your numbers. But this should have taken 2 minutes. So if you're in your 3, 4, 5 minute mark, you're wasting time. You're going to run out of time. So be careful about this. It can be a time waster. Honestly, I'd say run it through. If you get crazy numbers, stop, leave it, just get on with the rest of the paper. All right, scroll on up to part B. Part B then said, well, if this is the point of intersection of the planes, how far away is that from the origin? Well, that's just the magnitude of that point. So a couple of quick numbers, square root of 30. Top tip, if you make some crazy answer here and you're thinking, geez, I can't square 16 over 17 and 9 over 47, then for this mark, I would say part A is incorrect. Given intersection point is 1, 2, 3, and then do this, because then you're showing the marker, look, I know how to do this part, I get it, I screwed this up, but I know how to do this. Look, I'm showing you my skill of knowing the distance from the origin to a point. All right? If you get crazy numbers, don't even bother trying to do this. It'll only make it harder. Let's move on. Question 2. Here we go. What do we have? Okay, so this one was, the wording here killed us. The position vector R, which is the centre of the sphere, is this. Right? Read again. The position vector R, which is the centre of the sphere, was here. So here's my diagram. R, centre of the sphere. It also gave us this extra bit that the diameter was PQ. So PQ had to be here, And it said, oh, and the position vector of Q is that one there. So we really got the centre and one of the outsides of it. Okay? So what have I got to do? Well, here's one way I could have done it. P is equal to Q, so P's over here, is equal to Q plus 2 lots of QR. Direction's important. Or you could have said minus 2 lots of RQ. That would have been okay as well. However you did it, didn't really matter. 6 ways to solve it. Here we go, there's the answer. We've got our position of P. Scroll on up. Now the radius, well the radius, if we know, leave it there, if we know where Q is and we know where P is, we've really just got to do 1 minus the other absolute value of it, don't we? Or actually, sorry, from R to Q, not P to Q, that'd be the diameter. R to Q, 1 minus the other, absolute value it, and we'll get this. And then we recognise we want the vector equation, so this is the centre of the sphere. So it's R minus the centre, absolute value, equals the radius. So a pretty easy 2 marks, not really much number crunching, but a lot of understanding in that. Scroll on up. This is a great question, this one. I like this. I've seen it many times. If we want it to intersect with the y-axis, every point up and down the y-axis has an x value of 0 and a z value of 0. Okay, think about that. Every point on the y-axis has an x value of 0 and a z value of 0. Now I could rewrite this question and say intersects with the z-axis, so then x and y must be 0. So whichever axis you want to intersect with, the other two must be 0. Okay? So we end up with this, and the thing that we want to find is y equals a. Where does it cross over? So I just fashion up this one. And then because I've got the formula just above of that sphere, I just put this in as one of the points and calculate. And I made a bit of a mistake here, but I tidied it up. One of my students got it right, which was great. I had the wrong answer there. So my issue here was I went to square both sides, and I didn't even think about, I just went, oh yeah, look, that's fine, I can just move it all across, which is how I got here. But I forgot we need to square all of this side and all of that side to get rid of that square root, which is what I've done up there. And then you move a couple of things across and we end up with plus or minus 2 root 11, which makes sense that it's a bit of a plus and a minus kind of idea, because if it's a sphere, then there's going to be 2 points, most likely 2 points, where it crosses over. It could be 1 point, but that would mean the sphere only just touches the axis, right? Or it could be no solution, which would mean that it never crosses it. So a follow-on question here might be, interpret your answer in terms of, I don't know, the geometric interpretation. You would then say, given that there is 2 answers, the sphere must cross over at 2 points. Okay? Whereas if you got 1 answer, it would be the axis would be a tangent to the sphere. 0 answers, the sphere never crosses over the axis. So there's a bit more thinking in there that we could put a part D in, or part D if we really wanted to. Let's keep going. Here we go. What's the next one? Oh, easy one. Easy one. This should have been easy marks for a spec person. We're given 3 points, and we're told they are coplanar, meaning they sit on the same plane. One's here, one's there, one's there. They're coplanar. So if they are coplanar, from the origin, let's go to one of the points. Let's then work out from that point to another one, and then from that point to the third one, which is what I'm doing here. And now I've worked 3 out, you only need to work 2 out, okay? Because you go to 1 with your first point, a direction and a direction. Now the only thing you've got to be careful here in defining is to make sure that these 3 points aren't collinear, okay? The question says they're coplanar, but if they were collinear, you would not be able to define that plane. Let's think about that. If they were collinear, here's one, here's one, here's one. If they all fit along that line, collinear, then that plane that I think I'm defining actually could be rotated around constantly and define an infinite number of planes. So the fact that there's no common factor between these, tells me that they are not collinear, and therefore I know that I can actually define the plane by using these. If you saw a common factor between these, you'd have to go, hang on, I've either done something wrong or I've got to read the question again. Maybe there's something I'm missing. Okay? Coplanar on the same plane, collinear on the same line. Here we didn't have to worry because they weren't collinear. Easy, boom, done. It just said the vector equation. So we didn't have to think, oh gee, wait, maybe I need to do the r dot n equals a dot n. Any form would be fine, and I think this is the easiest form. You could do it in r dot n equals a dot n if you want to, but why make it harder than it has to be? Let's keep kicking along. Where are we? Determine the cross product, right. Okay, so this is really the question saying, do you know how to do it without your calculator? That's really all it's doing. So multiply it on out, come up to this one, or this one. I would have paid that. Now really that one is if you'd done them the other way around. Okay, you remember the right hand rule? The right hand rule, you would point one finger in the direction of one of the vectors, the second finger in the direction of the other one, and then where your thumb points is where the normal or the cross product of two vectors is going to be. Now of course if I do those two vectors the other way, then it will get me the other normal pointing up. So both of these are okay. Most people would have done W cross product V, because that's the order they're done in, but it's not wrong to cross product them the other way and get this answer here. But you can see one's just the negative of the other, which makes perfect sense. One's coming up out of the plane, one's going down into the plane. Easy. Let's go, last bit. And hence show that the answer from part A is indeed perpendicular to the plane which contains, oh, I missed a bit over there, to the plane which I missed it. Oh, everyone interpret that okay, I think. What we needed to do was dot the answer from this one, which was the normal, so that's the one coming out of the plane. We need to dot that answer to one of the vectors that we had on the plane. Okay? And we want to show that that comes up to 0. Again, you only needed to do one of them. I did both, so I had them there for marking. But we take the normal, which we just got above, which is at 90 degrees to the plane, and dot that to one of the vectors on the plane, should equal 0. And indeed, as you can see, it does, so I'm pretty confident there. A word that popped up the other day that I don't see come up in our textbook enough, or enough is much at all, is orthogonal. I'm pretty sure I've said that right. Orthogonal. If something is orthogonal, it is at 90 degrees. So we would generally term it as the normal to the plane, or perpendicular to the plane, but one vector that is orthogonal to another one is at 90 degrees. All right? So I just saw that wording and I went, oh gee, I must pop that in somewhere. Let's go, that's the end of part 1. Let's get into part 2 here. There we go. Right, where am I with part 2? Oh, I've lost my way here. Oh, I don't need that one. I think I need that one. All right, here we go. Good work. Right, so we've got a plane here, and we've got the normal. So we should be able to take that and just slot that straight into there, which is what I've done here. And because we know this point exists on the plane, can't I just put that into the right-hand side? And I can end up with this guy here. That's the right-hand side of it. And I come through to this. Okay? So I'm really just taking the information from the top, getting it in there. But something most people missed was the Cartesian equation. This is a vector equation of the plane. We wanted you to go, oh, well, therefore r is equal to x, y, z. So x, y, z multiplied out. I know it's the same information, but it did ask for the Cartesian form of it. Obviously, it had pushed you towards the vector form, but it wanted Cartesian as an answer. So 1 mark for recognising what to do, and then 1 mark for giving the correct answer. Okay? Like I put here, many started with plane P, rather than looking at this one, parallel to plane P, so we can take the same normal and passing through. So the question did start with plane P and then asking about Q. Maybe that's a bit rough, I don't know. Move on up. Determine the equation to the line that passes through A and is perpendicular to P. If it's perpendicular to P, then it's parallel to the normal, isn't it? Because if you've got a plane, the normal is defined here. Well, if you've got a line that is perpendicular to the plane, then it's parallel to the normal. Perpendicular to the plane, parallel to the normal. Hence, we just need to start with the start point and say, well, okay, lambda lots of the direction, any which direction you like. Because you've already, that is perpendicular to the plane. Remember, the normal can be defined anywhere across the plane. I just need to make sure it goes through that point there, so there's my point. Keep on going. What do we got next? Determine the position vector of B, the point of intersection with the line and the plane. Right, we're getting a bit more complicated now, but really all we're doing is we've got this formula here, right? That's that bit there and that bit there coming on down. But I've just taken the formula for the line that I just created and I've put the formula of the line in there. That's that one there. So I've just put the formula for the line into the formula of the plane. I made a bit of tidy up here. I always like to do this, to just tidy that up into one column vector, and then I do my multiplication. You can do some of this on your calculator as well, but I tidy it up just so I've got this here before I do my dot product to get here. Solve through to get lambda. Lambda I then go and put into the line to figure out where that point would be. Now again, with these questions, like I was saying earlier, if you get over here and you're getting crazy numbers, you've done something wrong, okay? We're never going to give you, even though it's a calculator section, we're not going to give you 14 over 19 as an answer, simply because that doesn't tell me any more about you as a student, okay? If you get 14 over 19, you're still following the same process as me making the answer come out to 3. So if you get crazy numbers coming out on these, in most cases, you've done something wrong. Now, would I go back and tidy up? I would probably say no. And the reason I would say no, in a calculator section, you can work this out pretty quick on your calculator and show the skill that we were looking for. But of course, you're going to lose at least 1 mark on the way through. But would it be worth your time to go back and try and find the mistake? Probably not. So my advice is get crazy numbers here in the calc section, just carry on with them, because the time to find the mistake could well not be worth the extra mark that you pick up, okay? Especially on something, say, 3 marks. Having said that, if this was part A, and I know that part B and C and D are going to rely on those numbers, then I'm probably going to spend the time to find the mistake. All right? Just be very selective with your time. Next one up, where are we at now? I'm losing my way here. Where are we at? Oh, distance between the planes. Okay, so here's our diagram of what's going on. This is the situation. A is on plane Q and B is on plane P. And here are our plane formulas. Right? Here are our plane formulas. So from, where did I do this? Oh, that's right. I changed this to 4 marks thinking, gee, this is going to be a bit trickier. Here we go. But actually, this answer was the answer above. So you kind of had 2 bonus marks. I didn't realise that the working here would be exactly the same as the working above. So really, there's 2 marks for an easy 3 saying, hey, it's the same as above. So then you just needed to put this into the other one and get the 2, keep scrolling down, get the 2 points. These 2 points are on the 2 planes, and they're the shortest distance because we were using the normal to find those distance, or find those 2 points. Subtract one away from the other, quick little number crunching, and we're here at square root of 54, which you can simplify, I think. What have we got? 9 sixes, so it'll be 3 root 6 if you want to simplify, which is not a bad idea. But calc section, so really you can put it in there and get a decimal if you really wanted to. So a lot of the work that I thought for that question actually was done above. Now, if you didn't realise, like I didn't, then you may well have redone the question and then gone, oh wow, I get lambda equals 3 again. Oh, that's convenient. Well, you're actually working the same thing out. But anyway, for those who saw what was going on, it was a bonus 2 marks. Rightio, this one. Where am I up to? Here we are. Right. Now, this is asking you to solve it if you can and give the unique solution. If you can't, then you need to interpret them geometrically. Tell me what they would look like. That's what I'm after. Tell me what they would look like. Now, when we get to this solution here and a single 0 there, this solution and a single 0, but be aware, that 0 could be there, or there, or there. doesn't matter which position it's in, okay? Then this is the situation that results. We've got three planes kind of crossing through on one line. Now we draw it like a top view here. That's the easiest way to draw it, I think. But of course that could be orientated anywhere in space. Oh, pardon me. There we go. Right, move on. These are only 2 marks, so if you can't see where you're going quickly, let it go. This one's solved really easily, so you put it on your calculator, hit solve, boom, there's the answer. 2 marks, that's all you need. Simple one there, last one. Right, now this one here, notice with these 2 equations, which you needed to do a little rearrangement here, these 2 equations, the x, the y and the z component is exactly the same. So that is telling you that the orientation of the plane in space is the same. The number at the end here is telling you that it's in a different place in space, but the orientation is the same. If the orientation between 2 planes are the same, then they are parallel planes. And if they are parallel planes, then they will never intersect. So between these 2 planes, we have no solution. The third plane is going to be one that will cut those 2 planes. So between here and here, I will get a solution that will be a line in space. And between here and here, I will get a solution that will be a line in space. But they will be completely distinct solutions. So therefore, I'm going to get no solution. This is the sort of thing that's looking here. Okay? Now, do me a favour. Scroll back up to the question. Keep going, keep going, keep going. Right. Oh, no, keep going, keep going. Up, up. Next one. Keep going, keep going, keep going, keep going, keep going. Keep top. Right. So this here is the same situation of those bottom 2 equations in that next question that I was talking about. Because, look, they're the same position in, the same orientation in space. This is telling me that they are a different position in space. Because, look, this could be written as x minus y plus 2z. X minus y plus 2z if it was in Cartesian form. And then if it's written like this, exactly would be x minus y plus 2z equals minus 7, or equals, minus 7. And then this would be x minus y plus 2z equals 11. So this here, and this situation here, now scroll back down for me, is exactly the same as here. X minus y plus z equals 1. X minus y plus z equals 3. They're exactly the same situation. Okay? And then in this, of course, we've got a third line that crosses them, hence no solution. All right, let's go. Last question I think we're on. No, second last. Second last. Here we go. Right, so this one is a pretty much bread and butter one. If you got time to get here, you should have got this. This is the way I do it, but I've got another solution on the back, which I think is more complicated. But you can jump straight to an answer and throw a couple of things in, which is neat. This is the way I do. I recognise that if I go from A back to the origin, and then I use the line formula to go to the line and some distance along the line. Okay? By doing minus OA or minus A plus, I'm really defining that vector there. And I know that this one is in the direction 3, 4. So if I dot that one against that one, it must equal 0 because the shortest distance is going to be at 90 degrees. So this here is going back to the origin plus dotted to the direction of this one. So this one in the square brackets is this line here, and then the 3, 4 is the direction of that line. Dot them together. You could do a bit of tidy up here if you want to. Dot them together. Numbers come out. Look, nice, easy numbers. Okay? And then it says about the distance. Well, I've just got to take that and put it into this one to find that point. And then it's really minus A plus to that point. And then the magnitude of. That's what this is doing here. This here is going back to the origin. This here is then going up to there. One minus the other to get that distance there. Absolute value of kind of falls out pretty neatly to 5. So pretty simple. Now let's leave the last question. Can you flick to the next page? Let's do the other solution, the other style. Now this is going to get a bit crazy here, okay? Now what I've done is we work down here and then we come over here and work down so you know where we're heading. This is our situation. We've got a line and we've got a point. And I've used the same numbers here because you'll see it works out the same. Okay? I'm calling this point in here B. Call it whatever you like. I called it B just to make it clear. And over here I'm calling that one C. Right, scroll up a little. So in that diagram, keep the diagram on board if you can. Right, in that diagram, sine of theta, which is this here, isn't that going to be opposite over hypotenuse? Opposite over hypotenuse. So AB over CA. That kind of makes sense for us. That's not drastic there. Now the distance AB, or the vector AB, the AB is really the distance that we want. That's really the thing that we're after here at the end of the day, isn't it? Okay? So we've got sine of that. Okay, fine. Let's move on. Up we go. So therefore, because AB is really the distance that we want, I could write this because I'm talking distances. So I want the absolute value of AC, CA, AB. I want the distances of those. I don't want the vectors of them. So I put some absolute values in there. Now if I multiply this guy up over there, I get this here. Okay? So that's my first statement that I'm going to go with, all right? So hold on that, scroll up. We also know that this formula works, right? That's the angle between two vectors that we use, okay? Angle between two vectors. So in this example, check it back later, in this example, these are the numbers, or the letters, that I need to throw in there, okay? If I divide both sides by the absolute value of L, on this side it'll cancel out, over here I get it in. So therefore I end up with that one, don't I? Now leave it right where it is. Now can you spot that this bit right here is what I worked out here, isn't it? So in place of that, I'm going to put in D, which, that's numbers over there. Scroll up, I think we're going to scroll up over here. Here we go. So therefore, I can come up with these two equations that I got from point 1 and point 2 over there. And you can see that there is that there. So I can come through with this one. Okay? So go try and get the diagram on there if we can. Okay, CA cross product L. Right. So CA is this one here. CA is this one here. Right? And we need to cross product that with L and then divide by the absolute value of L. That's what that equation is telling us. Okay? It's this one, cross product with this, and divided by the magnitude of L. Scroll on up. I've done the numbers for this one. So we put the numbers in. Looks a little bit crazy, but actually when we work that all the way through, we come up. This I think comes up to be, can't remember what that comes up to be, but this comes up to be 5, so that must be 125. And then because we're working out D, keep going up. There we go. Falls on out. So when we throw the numbers in, so you might want to look at this one. I think it's more complicated to understand, but if you can jump straight to this part, it's simpler to actually do the number crunching of. Okay? If you get stuck, the other style is absolutely fine. Let's go back to the last question. Last question was a cracker as well. There we go, right. So we've got some variables poking through here, 4 of them, which is probably not something you've done before, but we didn't need to solve for what they are. We've just got to say what they could or couldn't be. Now, I've done the normal reduction here. Scroll on up a bit. I've done the normal reduction here. That's kind of fairly normal. It looks a bit more complicated, but actually, you know what? When you did the right addition, a lot of it fell out pretty neatly. Up again. So then what I did is I got to this one here. Okay? Now, some people tried to solve it from here with some success. This was the better one because then I can just look at one row. Now, if I want, and the question said, for a unique solution. Unique solution. So therefore, this one here must be equal to 0, and this one here must not be equal to 0. Now, you could have done them the other way, but let's go the normal way. Equal to 0, not equal to 0, because then we would get a solution here for Z. Then we'd be able to go back and get the other ones. So if P minus R equals 0, then P must equal R, right? And if S minus Q does not equal 0, then S cannot equal Q. I think most people are okay there. Now this is the trick, not trick, but just the way I think you need to see it. if P equals R, well then I could just substitute anything I like, a constant K. Because it doesn't matter what it is, it's just got to be the same. So a constant K, well couldn't I then take that constant K, and if I multiply both sides here by K, then that's still exactly the same, isn't it? It'd be Ks cannot equal Kq, right? Or you can then say, well hang on, if that works, then it doesn't matter which side I put P and R on, because they're actually the same number. So if I put them on whichever side the question had a PS and QR, so I'll just put P and R on the right sides to match what the question told me, but indeed this could be RS is not equal to PQ. That would be exactly the same, all right? So there's a lot of thinking in this and a lot of spots to get lost, and it was the last question, so you probably only had about 2 minutes to look at it. Good questions on this test. I really think this test was a good test of your vector ability and your understanding of vectors. I accept that it wasn't an easy test. You had to move quickly and you had to think very quickly. So I understand it wasn't the easiest of tests, but it was a good test of your vector ability. I would recap this test, I would look over it, resit the test so that you can see what you're doing and see where you've made gains on that. Thanks very much everyone, hope you've enjoyed this. Catch you later.